Transketolase enzyme will transfer two carbon groups from ketose to aldose. Thus, the ketose which donate or give the two carbon atoms will become aldose, and the aldose which accept the two carbons will be a ketoses. Okay? Transketolase require thiamine pyrophosphate as a cofactor in the transfer reaction. You know the cofactors. The cofactors sometimes will be needed in the reaction. Transaldolase is the second enzyme that has a role in the non-oxidative pentose phosphate pathway. It will transfer three carbon groups in the same way done by transketolases. Okay, so the transketolase will transfer two carbon groups, while transaldolase will transfer three carbon groups. Okay, the 3 moles of 5 carbon sugar are converted via the enzymes of the pentose phosphate pathway and will be packed into 2 moles of 6 carbon sugar, which is fructose 6 phosphate, and 1 mole of 3 carbon sugar, which is glyceraldehyde 3 phosphate, as shown here in the last line in this diagram. Okay? The phosphate pathway can be recycled into the pathway in form of glucose 6-phosphate, generating more NADPH. Do you remember what did we say about the function of the NADPH? Of course you remember, right? Okay. Glyceraldehyde 3-phosphate can be shunted to glycolysis and oxidized to pyruvate. So the products which are fructose 6-phosphate and glyceraldehyde 3-phosphate. The glyceraldehyde 3-phosphate can be shunted to glycolysis and oxidized to pyruvate, while the fructose 6-phosphate can be recycled into pathway in the form of glucose 6-phosphate, which generating more NADPH. Alternatively, it can be utilized by the gluconeogenic enzymes to generate more 6-carbon sugar, which is fructose 6-phosphate or glucose 6-phosphate. Okay, this about the glyceraldehyde 3-phosphate. The last line will be explained in a good way in the next lecture, inshallah, which will be about the gluconeogenesis. Thank you.